These are the lesson 5.2 notes on ratio tables. In this section, we look at some new vocabulary. The first word is equivalent ratios. You can see the word equal in there and kind of like the word value. Equivalent ratios are two ratios that describe the same relationship. So they are two ratios that have equal values. They look a lot like fractions. You can think about them the same way you think about fractions. You can find equivalent ratios in two ways. The first way would be to add or subtract quantities, that means different numbers, in equivalent ratios like repeated addition. So this is like finding a pattern. If you're counting by twos, you're going 2, 4, 6, 8, and you're looking at how much it goes up in each step, and you're adding the same amount over and over and over. But it only tells you the next number. If we were graphing, it would be like finding the slope, right? And for example, if I have 2/3 and then I add a 2 in the numerator and a 3 in the denominator, then I get 4/6, which is equivalent to 2/3. And if I add another 2 to the numerator and another 3 to the denominator, then I get 6/9, which is another equivalent ratio. I've added the same number over and over in the numerator and the same number over and over in the denominator. So it's finding a pattern. It's similar to finding the slope. And really, that's the only reason that I included this option in these notes, is because I liked how it connected to slope. But in practicality, multiplying or dividing is a much better way to do it. You can also multiply or divide each quantity in a ratio by the same number, the same way you find equivalent fractions. And I wrote you a little note here that I like to do it this way because it's consistent with making equivalent fractions, and you'll make fewer errors doing this, and it will always work. Right? So I recommend this way. For example, if I want a ratio that is equivalent to 3/5, I can multiply my numerator by 3, and I can do the same thing in the denominator, and then I've got 3 times 3 is 9, and 5 times 3 is 15. When I multiply the numerator and denominator by the same number, I get an equivalent fraction or equivalent ratio. Right? And then we will look at ratio tables. That's what this set of notes is about. We're going to use ratio tables to organize our equivalent ratios. Right, so for example 1, we'll start pretty easy. Find the missing values in each ratio table and then write the equivalent ratios. So we've got one pen to every 3 pencils. So if I want to go up to 2, I can see that I could do this with repeated addition, but since I like the multiplication way better, I'm going to go ahead and do it with multiplication. I can see that from going to 1 to 2, I multiply by 2, so 3 times 2 is 6. So that makes an equivalent ratio. And then if I want to get from 3, I can't get easily from 6 to 9, but I can go from 3 to 9. So 3 times 3. So here I'm going to go 1 times 3. And 1 times 3 is 3. And then it says write the equivalent ratios. So 1/3 is equal to 2/6, which is also equal to 3/9. And you can see I was adding 1 in the numerator and I was adding 3 in the denominator. So if I was finding the slope of this relationship, it would be 1/3, going up by 1 in the numerator, going up by 3 in the denominator. All right, let's look at another example, but very similar. If I want to go from 6 to 12, that's times 2. So I do the same thing in the numerator, or I guess that's the top of the ratio table. So 4 times 2 is 8. And then if I want to get out here to 24, I could go 4 times 6, or I could do 8 times 3. And here I'll do 12 times 3. Whatever I do to the top, I do the same thing to the bottom. So ratios and fractions are different, but they look similar, and you can handle them very similarly. If we write the equivalent ratios, I've got 4/6 is equal to 8/12, which is also equal to 24/36. And then you have a couple of U-tries. We've got plantains and bananas. You guys ever had plantains? They look like bananas, but they don't taste like bananas. They're kind of starchy, and they work better in kind of savory applications. I wonder if we have some people who eat plantains in our class. We should remember to ask. If you eat plantains, tell me about that in class. And then we have euros and dollars. Euros are what they use in the European Union, and dollars are what we use in the U.S., and so we're comparing those ratios. All right. Now we're going to make a ratio table, and we will do it two ways. We'll do it with the addition way, and then we'll use the multiplication way, and you can decide which way you like better. So if you are making sugar water for your hummingbird feeder, a website indicates that you should use 4 parts of water. 4, that means like the little dot dot, to every 1 part of sugar. Okay? And now it tells us that we're going to use 20 cups of water. How much sugar goes with 20 cups of water? So we could make a ratio table where we find every step. We use repeated addition. You start out by writing down the things that you know. I know the amount of water that in my original recipe, and I know the amount of sugar in my original recipe. Maybe we should label that. That's the recipe. That's what you know. And then here's the thing that we're trying to get to. We want to get to 20 cups of water. So you make a table to get you to 20, and then you just add up. So I had 4 here, so I added 4 more to get to 8, and then plus 4 more, and 4 more, and 4 more. And then on the bottom, I added plus 1, plus 1, plus 1, plus 1. Right? And it just keeps going up so 4 over 1 is the same as 8 over 2, which is the same as 12 over 3, which is the same as 14 over 4, which is the same as 20 over 5. All right? Or 4 parts water to 1 part sugar is the same as 20 parts water to 5 parts sugar. All right? So that works, but you have to write down every step. You can't skip anything in between. So you can imagine that if you were working with a big number, like what if you were feeding a whole bunch of hummingbirds and you wanted to use 100 cups of water? That would be a really long chart. Using multiplication is quicker, and because it is quicker, you're likely to make fewer mistakes. It's also the same as fractions, and so you're likely to make fewer mistakes. You could again start with the recipe, so it starts the same. But now instead of having to find every step, you can go times 4 times 5 makes 20, and 1 times 5 makes 5. Repeated addition is the same thing as multiplication. This time I had to take 4 plus 4 plus 4 plus 4 plus 4, so I had 4 times 5. And here I was adding the 1 over and over and over again, so I had 1 times 5. Right. You have a similar problem in your U-try. Now we want to know, what if you use 24 cups of water? How much sugar do you need? So you want to go ahead and make your table. Do the water and the sugar. You're using that same ratio of 4 parts water to 1 part sugar. and then you need to get to 24. So whether you do that in one step with multiplication, or whether you do the repeated addition to get out there to 24, you have to find that number, okay? And then you have another you try that is similar. You now decide that you're going to make a sweeter mixture of sugar water, and this time you're going to be using 3 parts of water for, that's the little dot or the 2, every 1 part of sugar. So we're using less water, so it will be more sweet. And the thing that confuses kids on this sometimes is that it says 9 quarts. It skips to quarts instead of cups, but it doesn't matter because since it's talking about parts, the part could be cups or the parts could be quarts. All right, so just work it exactly the same as you did the other problem and figure out if we are starting with 3 parts of water, how we get to 9 parts of water. All right, and then we have 2 problems that are a little bit challenging. Now we will use a ratio table to solve a problem. The nutrition facts on a box of crackers shows that there are 240 milligrams of sodium in every 36 crackers. You eat 15 crackers. How much sodium do you consume? So that's kind of a hard problem, right? 15 and 36, those are not nice fit numbers. 15 does not go evenly into 36. How are you going to figure that out? First, start by writing down what you know. So make the table, and I know that I have 240 milligrams in 36 crackers. So record the information that you know, 240 milligrams in 36 crackers. Okay, and then we have to figure out what we want to know is 15. So here's the 15 that we're going to. So now I have to find I can't go straight from 36 to 15. 15 is not a factor of 36. So you need something in between. So I'm looking for a common factor of 36 and 15, some number that goes into both of them. And the one I'm going to use is 3. So the book put this in here, and I'm not sure why, because you don't need this piece of information. I can recognize that 3 goes into 15, and 3 also goes into 36. It's a common factor. And I think it's the GCF, but it doesn't even have to be the GCF. You just have to find something in common. All right, and so to get from 36 to 3, I divide by 12. So whatever I do here, I have to do here. So that's divided by 12. And then to get from 3 to 15, I multiply by 5. So to get from 20 to 100 is also times 5. So so the answer to that problem would be 100 milligrams of sodium. That was pretty challenging, huh? All right, so let's do, and here's some words to kind of walk you through that. All right, so let's look at it for 21 crackers. Okay, let's make the little chart again. So let's do sodium and crackers. Always start by writing down what you know. And once you write down what you know, it'll point you to where you want to go. All right, and I know that 240 milligrams of sodium are in 36 crackers. And I bet I'm going to have something in between. I want to go to 21 crackers, right? So I need a number that goes into both 36 and 21. You can use your multiplication chart and look for a column or a row that has both 36 and 21 in it. I know that 3 goes into both of those. This is 3 times 12, and this is 3 times 7. So I'm going to put 3 I want to do? Yes. All right. So to get from 36 down to 3, I had to divide by 12. Sorry, I should have given myself more room there. And I know that 240 divided by 12, I believe is 20. Let's make sure. All right. So you're finding a common factor. You divide both the numerator and the denominator, or the top and the bottom, by the same thing. And now to get from 3 to 21, that's times 7. So I have to take the 20 and multiply by 7. And 20 times 7 is 140. So this is 140 milligrams of sodium. All right? So sometimes you can do it in one step. You can find an equivalent fraction or an equivalent ratio in one step. And sometimes you have to have a middle step where you find a common factor. Right? The U-try is exactly the same. You're going to set it up the same way, except now we're looking for 24 crackers. So you're going to have to find some sort of common factor between 36 and 24. I wonder if I can find my, oh, here it is. If you have your multiplication chart and you're looking for common factors, what you're doing is looking for a row. Like I ended up using 3. If I go down to 3, I can see that it had both 21 and 36 in it. So you're going to look for a row that has 24 and 36 in it. This is, oh, look, you could also use 3 for that one. Okay, you could use 3. There might be another one, but 3 will work for sure. I think there's a bigger one. Okay, the last problem is pretty challenging. Okay. This will not be, well, this one's pretty challenging, but I'm going to walk you through it. You mix 3 pints of yellow paint for every 4 pints of blue paint to make some green paint. Okay. Some green paint with a little bit more blue than yellow. Okay, we can all visualize what that looks like. So here's my chart, and I've got 3 pints of yellow to 4 pints of blue. You use 10 pints of blue paint. I should have. I might wipe this out before I put it up, so that you guys have to go through the work. All right. So this one's hard because it will have some fractions in it. I'm going to do my fraction work right here. All right. So I want to get from 4 to 10. And when you make the little chart, 4 does not go evenly into 10. So you know you have to have kind of a midpoint. So ask yourself, what number is a factor of both 4 and 10? And I know that 2 is the only number that goes evenly into both 4 and 10. All right, here comes the tricky part. This is divided by 2, right? 4 divided by 2 is 2. What is 3 divided by 2? 1.5? Yes, it is 1.5, and we're going to write 1.5 as 3 divided by 2. So we're going to write it as a fraction in there, okay? And then to get from 2 to 10, I know that I have to multiply by 5. So I'm going to take that 3 over 2, and I'm going to multiply that by 5. And then I'm going to come over here and do that in some side work. 3 over 2 times 5 over 1 is 15 halves. And most of the time I would like for you to leave it like that, but I think in the context of the problem, 15 halves pints is kind of weird. So I'm going to simplify that down to 7.5. So you have to look at the context of the problem and see what makes sense. It makes sense to talk about 7.5 pints of yellow paint. It was pretty hard, huh? The thing that I really want you to notice is that you multiply or divide both the numerator and the denominator by the same number. I think I will do number 6 with you, all right, just because that's kind of hard. All right, so what if in this example we had 2 pints of yellow for every 3 pints of blue? What are they actually asking you? How much green paint? Okay, so it's the same problem. So let's go ahead and make the same chart. We've got some yellow, and we've got some blue. But this time they are changing the proportion. So now we've got 2 pints of yellow to every 3 pints of blue. And I'm going to use 5 pints of yellow. How much green will that make? Oh, that's so tricky. Look here. I missed something. It didn't ask how much yellow, it asks how much green paint. So to find the total, go back up here. To find the green paint, equals 7.5 plus 10 equals 17 and 1/2 pints. Always read the whole problem to see what they're actually asking. Okay, how to add the yellow plus the blue together to get the final answer. Okay, so back to this problem. 2 pints of yellow to 3 pints of blue, and we're going to use 5 yellow. So now I need a common point, and I don't see anything in between here, huh? I wonder if I could go up. Do you think I could multiply and have 10 here in the middle? Huh. So it doesn't have to be just a common factor. It can also be a common multiple. What do I do to 2 to get 10? This is times 5. So 3 times 5 is 15. And then to get from 10 to 5, I divide by 2. So now I need 15 divided by 2. 15 divided by 2 is also, that's interesting, 7.5. Last time I used 7.5 blue. This time I'm using 7.5 yellow. And then to find the green, I have to add those together. So I've got 5 plus 7.5 equals 12.5 pints of green. All right. I know the fraction ones are kind of tricky, but I thought it was important to include them so that you could see that it works, and that if you just take it step by step, if you multiply or divide the numerator and the denominator by the same thing, then you can make an equivalent fraction even, or an equivalent ratio, even if it has a fraction in it.